Hello learner, welcome back to our YouTube channel Roboarmy. In today's video, we are going to build a smart road safety project called the ActiBump System. This system is designed to automatically raise or lower a speed bump based on the speed of the vehicle. You must have noticed that normal speed breakers slow down every vehicle, even ambulances, emergency vehicles, or vehicles moving at a safe speed. So the question is, what if the speed breaker activates only when a vehicle is overspeeding? That's exactly what our ActiBump system does. In this project, we use two IR sensors to calculate the speed of a moving vehicle. If the vehicle crosses the speed limit, the servo motor raises the bump. If the vehicle is within the safe speed limit, the bump remains flat. A 16:2 LCD display with I2C module shows real-time message like vehicle detection, speed and warnings. Now let's quickly go through the components required for this project. Arduino Uno as the controller, two IR sensor to detect vehicle movement, servo motor to raise and lower the speed bump, 16:2 LCD display with I2C module, breadboard, USB cable to upload the code, battery pack or external power supply, jumper wires. Before moving to the code, let's understand the circuit connection step by step. First, take the Arduino Uno and the breadboard. Connect the 5V pin of Arduino to the positive rail of the breadboard. Connect the GND pin of the Arduino to the ground rail of the breadboard. Now take IR sensor 1, which will detect the vehicle first. Connect its VCC to the positive rail. Connect GND to the ground rail. Connect its out pin to digital pin 2 of the Arduino. Now take IR sensor 2, which detects a vehicle after it travels a short distance. Connect VCC and GND similarly. Connect its out pin to digital pin 3 of the Arduino. The distance between these two IR sensors is fixed and we use the distance to calculate the speed. Now take the servo motor. Connect the brown wire to GND, connect the red wire to 5V, connect the orange wire to digital pin 9 of the Arduino. The servo will act as our movable speed bump. Now take 16:2 LCD display with I2C module, connect VCC to 5V, connect GND to GND pin, connect SDA to A4 of Arduino, connect SCL to A5 of Arduino. Once done, recheck all connections carefully according to the circuit diagram. Let's move on to the coding part. Download the code and the required libraries from the link given in the description below. Open the Arduino IDE and paste the code. In this project, we use three libraries: servo.h to control the servo motor, wet.h for I2C communication, liquid crystal underscore I2C.h to control the LCD display. We define IR sensor pin, servo pin, distance between two IR sensors, speed limit set to 10 km/h for demo purpose. We also define two servo position, flat position when the bump is down, up position when bump rises slightly. Now inside the setup function, we set both IR sensors as input, attach the servo motor to pin 9, initialize the LCD and turn on its backlight. Display startup message ActiBump system ready. Now this is where the main logic works. When a vehicle passes the first IR sensor, the system notes the current time. LCD shows vehicle detected measuring. When the vehicle reaches the second IR sensor, the system notes the second time difference is calculated using distance between sensor and the time taken by the vehicle. The speed is calculated in km/h and displayed on the LCD. Now, if the speed is greater than the speed limit, the servo raises the bump, LCD displays overspeed. If the speed is within the limit, the bump remains flat, LCD displays safe, welcome. After a few seconds, the bump resets to the flat position and waits for the next vehicle. Now, let's upload the code. Connect Arduino Uno to your computer using a USB cable. Select board Arduino Uno, select the correct COM port, click on the upload button. Once uploaded successfully, make the structure out of a cardboard like this and attach the component as shown. Now power the Arduino using a battery pack. Here's how the ActiBump system works. The system starts and displays readiness on the LCD. When a vehicle approaches, the speed is calculated automatically. Overspeeding vehicle triggers the bump. Safe speed vehicle pass smoothly without any bump. This makes the system smart, efficient and suitable for modern road safety applications. So this is how we can build a smart ActiBump system using Arduino. If you found this project helpful, don't forget to like, share and subscribe to Roboarmy for such amazing projects. Thanks for watching. Happy learning.
Roboarmy. One-stop global community for teens in robotics and AI.